The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody, and welcome to today's welcome to today's webcast. Today, we're going to be discussing wireless solutions for conference room applications. My name is Cheryl Jennison DeProsa, speaking to you from lovely Shure corporate headquarters here in Niles, Illinois. And today, as always, I'm joined by Gino Sigismondi, the manager of system support, and we have a special guest, Paul Gunya, who is an associate product manager, and he's also going to be helping us go through some of these wonderful solutions we have for conference rooms. So before we get into the meat of today's presentation, just a few items of housekeeping. First of all, this webinar, as they always are, is being recorded. You can always go to www.shure.com/training to find all of those archived webinars. So if you want to go back and re-review this or direct a colleague to it, or if you want to check out some of the past ones, go there, check them out. They are all available. Secondly, if you have any questions throughout the course of today's webinar, we welcome you to type those into the question pane. It's in the upper right-hand corner of your screen. If for some reason you can't see it, just look for that little orange arrow and press that, and that'll maximize the little question dashboard. And we will get to as many of those as possible at the end of the session. So without further ado, I'm going to pass things over to Gino. Take it away, Gino.
Okay, great. Thank you, Cheryl, and thanks to Paul for being here, helping us out today. As we're going to talk about really exciting new product. Actually, is kind of really the sort of the impetus for this particular topic. Again, as we note here, it's wireless solutions for conference room applications. There are a couple of different solutions for this. But the new Microflex Wireless product line that we have is a system that was sort of designed from the ground up for this particular application. A lot of times when you think of conference tables, you think of very particular type of microphone, gooseneck microphone, boundary microphones, small unobtrusive microphones for meeting and conference applications. And this is not necessarily a new idea. It's something that we've been getting requests for here for a long time. And back in the old days, about 10 years ago or so, if you wanted to do this, you kind of took a Bodypack transmitter and kludged up a way to connect one of our Microflex gooseneck mics to it and tried to find somewhere to hide the Bodypack under the table, and that was your wireless gooseneck microphone. We've come a long way since then, and let's dive right into it and see what we're looking at here. I mean, again, who needs wireless conference mics? Well, you can see the laundry list of different possible users for this type of thing here. But it really kind of comes down to a couple of really sort of specific use case scenarios. One of which is the sort of versatile meeting space or convertible meeting space where tables are rearranged and the room is never set up in the same way twice, but you still have a need for high quality audio conferencing or even sound reinforcement for those types of applications. Running cables every time is kind of a pain and not necessarily a good option. So whenever you've got these kind of reconfigurable rooms, there's usually a strong need for a wireless solution to go with it. The other possible scenario you might run into, particularly in higher end boardrooms and conference rooms, is they spent half a gazillion dollars on some custom made table that you're just absolutely not allowed to put holes in. There cannot be any holes in the table, therefore we cannot run any wires to the table. But oh, by the way, we need microphones. In that scenario, well, wireless is pretty much the only way to go. So that would be another, again, kind of application for high quality, good sounding conference microphones that just happen to not be able to have a wire attached to it. So the requirements in this application are maybe somewhat different than you might have from a typical, maybe more professional AV, I shouldn't say AV, touring sound or musical application type wireless system. In these scenarios, the microphones are usually stationary. They're sitting on a table. They're not wireless for the purposes of you don't want to trip on the wire, but wireless because you can't get a wire to the microphone even though the microphone is stationary. Typically shorter range is common in these applications, again, than you would out of like a broadcast application or some stadium application where you need hundreds of feet of range. It's not typically what we're looking at here, thinking more kind of within the range of a typical conference room or maybe a ballroom or something like that, being about the largest room you might be in. Long battery life is definitely important here because we're not necessarily talking about an hour or a 2-hour gig. We're talking about potentially day-long meetings, needing 7 to 8 hours of continuous reliable runtime from a battery. The design has to be unobtrusive. In these applications, people typically don't want to see the microphone. What they do see needs to look good and look professional and look corporate, so that it kind of fits in with the meeting space. Of course, it's got to sound good, right? Quality voice reinforcement. Again, maybe not the same as you would have in a musical application. We're not talking about bass guitar frequencies needing to be reproduced here. We're just talking about a good, natural sounding human voice. Obviously, more than just saying it's intelligible, right? Because telephones are intelligible too, but they don't sound all that good. So we're trying to be several steps above that and giving natural, good sound quality. And then security is often important, especially again in a lot of maybe government or higher end applications, where you don't want to be scared that someone else is going to be able to listen in on your wireless signals from your microphones during your meeting. So security is often something you want to look for here. As I said, this is not a new application, and we have a slightly older legacy product that was an initial attempt at creating wireless gooseneck and boundary microphones for conference room applications, and that's the MX690 boundary and 890 gooseneck base that you see here. So there's actually no gooseneck plugged into it, but it's modular. So a gooseneck microphone would be selected to go with that 890 base. And those work on the SLX platform. So you would couple those transmitters with an SLX4 receiver, one per transmitter, to put together a wireless boardroom type system. And this, as these things go, is a relatively affordable way to go. Obviously more expensive than wired mics, but as wireless goes, not too expensive, terribly expensive. And it's a system that was from a familiar setup for people who are used to setting up other professional UHF wireless mic system. It pretty much works the same way. You scan for frequencies on the receiver, and you sync up the transmitters to the same frequency. And that's how it works. Again, it's really very similar to any other pro UHF system, and it sounds pretty good. It used our Microflex wired mic goosenecks to connect to that base if you needed to, or the Microflex caps on the boundary mic. Good sound quality there. However, given what we just talked about for some of the requirements for this type of setup, there's a few things that maybe make it less than ideal. One of the things that is complicated about this system, and I guess not any more complicated than any other UHF analog wireless mic system, but is frequency coordination, particularly in applications where you want to run a lot of wireless microphones in your conference room or for your meeting, uh, and you may be in a crowded urban area where there's not a lot of open spectrum because of how crowded the UHF television band can be in certain areas. It can be really tricky to coordinate a large number of compatible channels for these types of applications. Often you have to mix and match frequency bands, which makes the coordination even more complicated. And it's definitely something you need to be aware of and pay attention to if you're going to use this system, as well as all the antenna setup stuff. Remember, if you're using more than 2 or 3 mics, you've got a whole bunch of receivers in a rack somewhere, and you've got to have antenna distribution and possibly remote antennas and dealing with antenna cable and cable loss and all of that other good stuff, which again is something that's, if you're used to doing large channel count with UHF wireless systems, you're used to doing this, but it is something that definitely needs to be paid attention to here. Battery life, these use AA alkaline batteries, which can vary. Sometimes get you all the way through a day-long meeting, sometimes maybe not, and the only real metrics you get are a low battery indicator on the mic telling you your battery's low, you should probably change it. They're physically kind of large, I mean, at least compared to some of the newer things that are out there, but not too terribly large. And kind of a big thing though is that they're not encrypted. So again, this is analog UHF transmission, where they got any other receiver, analog receiver that can do FM could possibly listen to one of these. So they're not secure by any means. However, still current products, still a good kind of entry level type solution for someone just looking to get into a couple channels of a conference room mic system. But let's move on to the new system, the Microflex Wireless, which is, we think, addresses a lot more of the kind of needs of this particular type of application in a much more elegant type solution. Just a quick high-level look at some of the features that are common to the system, and then we'll look a little more deeply at some of the components. Of course, it sounds really good. It's still the Microflex cartridges that are well known and well liked, coupled with now a digital audio platform, which does away with all the companion noise and other things that can sometimes plague an analog system. It's really the most transparent audio you can get out of a system like this. And it takes advantage of the Dante digital audio networking platform as well for keeping the system all digital if you would like, or breaking it out to an analog output if that becomes necessary. Second thing that's really, really huge is the automatic frequency coordination or frequency management that's part of Microflex Wireless. Essentially, it takes care of itself. Traditional frequency coordination in terms of running software like our wireless workbench and having to coordinate compatible channels and scan for clear frequencies and consult tables, DTV channels to make sure you avoid DTV. You don't have to worry about any of that stuff. In fact, it doesn't even operate in the UHF television band. The system operates in the 1.9 gigahertz, what we call DECT band, which we'll talk a little bit more about later. But one of the advantages of working in that band, aside from the fact that there's no DTV or other kind of stuff, is the fact that the system, again, the way it works in that band is it scans and coordinates, deploys, manages frequencies with really no interaction required by the user at all. More details on that later. Again, as I mentioned already, Dante Digital Audio Networking is part of this system. There's AES-256 encryption for secure meetings so that you don't have to worry about someone being able to listen in, even though you're using wireless mics. They look good. They're unobtrusive, nice design. They fit into high-end environments. There's a smart rechargeable battery solution here, which is actually borrowed from the same lithium ion rechargeable technology that we're using in many of our other products now. In fact, if you were on the last webinar we did back in June, that was specifically on the topic of rechargeable batteries as it applies to Shure wireless systems. And if you would like more detail on how that works, I actually encourage you to go back and look at the archived version of that webinar on our website, because there's tons of detail on all the technology that goes into our batteries. But that same technology is now moved forward into the Microflex Wireless solution as well, which gives you long continuous runtime, great battery metrics, all in all, a really good solution. In fact, these Microflex Wireless microphones, when they're fully charged, can typically run for about 9 hours, which will get you through a day-long meeting easily. And finally, all of this is controlled by a web-based GUI that you can just get to through your browser on your computer. So you don't need to install any special software to be able to control the system. And we'll look more at the GUI a little bit later on as well. So a quick overview of the components that comprise a Microflex wireless setup here, starting with this thing, the access point transceiver. You're going to see that word transceiver here a lot because, again, unlike a traditional wireless microphone system where we think of a transmitter, which is the microphone part of it, sending signal to a receiver that picks up that signal and sends it back, there's a lot of two-way communication going on in this system, signals going back and forth between this device, which we refer to as an access point, and the microphones. But if it helps to wrap your brain around it in terms of thinking of a typical traditional wireless mic system, think of this as kind of more of the receiver. This is the device that will pick up the signal from the microphones and send it on to the rest of your sound system. This is available in 4 and 8 channel configurations. So when you look at this, it looks like one thing, but depending on which one you buy, it actually replaces what would be traditionally 4 rack mount receivers or 8 rack mount receivers. And this goes in the room. It doesn't go sitting back in a closet somewhere so that you need to remote out a bunch of antenna cable to get your antennas in the room. The antennas are built into this. The receivers are built into it. It's all of it in one channel, including transmission as well. The 4-channel version of this can send 1 channel of audio back to the microphones. The 8-channel version can send 2 different audio signals back out to the microphones. So it actually, again, is transmitting and receiving at the same time. But its primary function is to pick up the microphones and then send the signals on from there. Huge advantage here, again, is no remote mounting of antennas. The antennas are in here. This thing goes in the ceiling or on the wall in the meeting room, connects to the rest of the sound system, well, to the rest of the network via Cat 5e or Cat 6 cable. The docking charger, which you see here along with the microphone sitting in the docking, is another big part of this system. Again, I mentioned it's a rechargeable system, so of course you would need some sort of charging device to charge the microphones. It serves that function, but it also is a networked device that is part of the overall system, and that's what helps you link transmitters or microphone transceivers to access point channels. So if you've got a 4 or an 8 channel receiver, right? There's 4 receivers in that box. You need to assign microphones to channels 1, 2, 3, and 4, and that's easily done via the network charger. And we'll see how that's accomplished a little bit later on. But it's more than just a charger, it's actually part of the system. You can see we have 4 different types of microphone transceivers. Again, there's that word again, because again, they transmit the signal from the microphones. They receive the back channel audio from the access point. So they are indeed transceivers. And we have, of course, boundary and goosenecks like you would expect in this type of conference mic setup, as well as Bodypack and handheld transmitters. And then finally, not pictured here, but we'll talk about a little later on, is the audio network interface. Again, what's coming out of the access point transceiver is Dante digital audio, and you may need to get analog audio out of the system again at some point, and that's what the audio network interface device provides for you, is getting some analog to connect to the rest of your sound system if that's needed. So here's a little bit closer look to some more details on the transceiver here. This device is powered by PoE, or power over Ethernet. That's kind of a key thing to look out for when you're connecting your system. If your transceiver doesn't seem to be turning on, it's probably because it's not plugged into a PoE port somewhere. So make sure you're looking out for that. See the dimensions there. It's fairly small, 7 by 7. It looks a lot like any other access point type device that people are used to seeing in corporate enterprise applications. So it fits right in, but it does have a paintable cover that's included with it as well. So if it needs to match a certain decor, you just paint the cover, put that right on top of the access point, and away you go. Again, the antennas are internal. It's a circularly polarized antenna design. It actually is diversity as well. You wouldn't know that by looking at it because you can't see the antennas, but it is. And it has a roughly cardioid-like pattern to it, if that helps you kind of figure out what sort of pickup you would get from something like this. Again, it can be controlled and monitored via the browser-based GUI. It's also controllable via third-party control, Crestron, AMX, that sort of thing. In fact, the control strings for that are already available in the FAQ on the Shure website if you needed to take a look at those. And as I mentioned earlier, 4 and 8 channel versions are available of the access point. Here's the 4-channel version of the network charging station. Again, as I mentioned, there are both 4 and 8-channel versions. This is the 4-channel. One thing to note here on this is that you'll note that the docking connectors are actually a A-type USB connector. It's a standard type connection point. It's a pretty rugged and reliable connection, so you get a nice satisfying click when you put the microphones in the charging station to know that they're connected properly. So as you would guess, then the microphone transceivers themselves have the mating connector on this, and that kind of allows sort of a unique powering application for these, because if you are running a meeting that happens to be going longer than 9 hours and your battery life is running down, but you need to keep the meeting going, you could literally use any USB type charging device, like to just plug it into power and keep the microphone going for even longer if you need to. In fact, you could even plug it into the USB jack on your computer, and if your computer is plugged into AC power, that would actually power the microphone. So it's a solution for needing to run even longer. It's a question we used to get a lot about our even with the MX690 and 890. People would sometimes ask us, like, well, I don't want to use batteries on those. Is there any way to provide DC power to those? And I would always scratch my head and think, well, but then it's not wireless anymore. So what's the point? But a lot of times in conference tables, you will have AC power built in. You will have you will have network connections, but they don't have a mic connection there, and they don't want to run a mic connection there. So providing power is not necessarily the problem. It's just the mic signal that's the problem. And again, if you've got power on the table and a USB power supply, away you go. So again, that's how those work there. Something to note is what you're looking at here. The close-up there is of the connector for the gooseneck microphones, which is on the back of the microphone transceiver. All of the other ones go vertically into the slots that you see in the middle here instead of horizontally like the goosenecks do. An interesting point to keep in mind then, though, is if you slide a gooseneck mic into one of these slots in the back here, it covers up the two docking slots. So what that translates into is you need twice as many network charging stations if you're using gooseneck microphones. So in other words, we could fit 4 boundary mics in here. We could fit four handhelds. We could fit 4 body packs, but only 2 goosenecks. So if we needed to charge 4 goosenecks simultaneously, we would need 2 4-channel charging stations there. The charger also shows you how close you are to being fully charged with the LEDs across the front there. Again, as I mentioned earlier, it's networkable. And the link button, which you can kind of see over on the left-hand side here, is part of your setup process, which is how you link microphones to the system. And again, we'll take a little bit closer look at how that works later on. So looking at the different transceivers here, again, this is the MXW6, which is our boundary microphone transceiver. It is available in cardioid or omnidirectional pickup patterns. Of course, it's rechargeable. We talked about that. If you look really close, you might be able to see the headphone jack kind of over on the side of the microphone here. And again, that's where you would get your return audio back if you are sending any return audio into the system. The push button on the top is a programmable button. You can have that set up via the GUI to behave in a number of different ways: push to talk, push to mute, or function as a toggle switch. It can also function to wake the microphones up from something called standby mode. Paul, maybe you can talk a little bit about what standby mode is and why we put that in here.
Sure. Standby mode is a mode which you're going to use to kind of keep the mics where they are. It's an audio mute, but the RF connection stays up. What this does is it goes into a kind of a low duty cycle RF. It kind of pings the access point every half second or so and says, "Hey, do I need to do anything?" And if not, the mic stays in this low power state. Think of it as the sleep on your laptop. So it uses about half the battery. So when mics are in standby, we're actually specking around 24 hours of battery life in standby. So think about setting up a conference early in the morning before everyone gets into the room. Then from one button from the GUI or locally, you could wake all the mics up and you're ready to go. So it's just to build in some more flexibility and to give the user some more options.
Wow, that's so 24 hours when it's in standby mode?
24 hours.
Wow. Okay, that's good. Cool. And then so as you were saying, right, so you can program, so either one button push wakes up all the mics or it just wakes up that mic locally. Is that right?
Correct. You can set that all up from the GUI. You have the choice.
And now there's a power switch underneath the microphones. If you actually use that to fully turn the mic off, then that's off, right? Like there's no way to just wake them up with the push button on top, right?
Right. Once the mic is off, it's off. It's not transmitting any RF. It's not transmitting any audio. So you have to go back to the physical microphone to turn it back on.
Okay, cool. And that's a feature that is any of the MX transceiver mics, right? They all have that same standby functionality.
Yes, they all have standby. However, the Bodypack and the handheld have a dual purpose button. They don't have a separate power button. You hold down their one push button to turn them on and off.
Okay.
Quick question about that. Is there a visual indicator for that standby mode?
Yes. So in the GUI, there is a yellow indicator telling you that they're yellow or telling you that they're in standby. And there's also a slow kind of a pulsing red light to indicate on the microphone itself that they're in standby.
Good. Excellent. Good question. Okay, so here's the gooseneck mic, the MXW8. This allows you to choose from 3 different lengths of gooseneck microphone that you can put in here. And it's the same modular design that the MX series goosenecks use. So the MX405, 410, and 415, which would of course be 5, 10, and 15-inch gooseneck microphones, will all work with the MXW8, and that's something that can be purchased separately if needed. And there's also two different LED versions of the goosenecks as well. What we're looking at here is the kind of more common version, at least in the United States, which has a bicolor LED in the base. So it glows green when the mic is active and red when the mic is muted. There's also a light, what we call a light ring version, which has an LED at the top near the mic element itself rather than at the base, that is off when the mic is off and red when the mic is on. So there are those two different options available there. Again, rechargeable headphone jack, just like all of them do. Power switch hidden underneath, like they all have as well. Here's kind of a unique sort of thing here, which is our body pack, which is called the MXW1. And it's called a hybrid body pack because it actually can be used as you would a traditional body pack transmitter, plug a lav mic into it or a headset mic into it. But if you don't want to, it's actually got a microphone built into it right on the top. You can kind of see it in the close-up of the top here. That's actually an omnidirectional microphone. So you could put this in your shirt pocket or hang it around your neck with a lanyard and just use this as literally as the microphone itself if you so desire. But if you're going to use it again with a lav or a headset, it's the same TQG connector that all Shure microphones of that type use, and it has an auto switchover function so that when you plug the microphone in, it will automatically switch over to the plugged-in microphone, so you don't have two mics sitting there active on the body pack itself. And Paul, if I understand this correctly, in the GUI, there's a way to defeat that auto switchover so it will stay with one mic or the other?
Correct. So in the GUI, you'll have a few options. You will have control over the gain of each microphone. So you will have control over the internal Omni separate from the external TQG connector. You also have an indicator of which microphone is active. And then you could select basically a force on for one of those microphones. So if you always want to use the TQG and never use the internal Omni, you basically set it to external only mode, and as you plug in and plug out that TQG, it will not switch to the Omni at all.
Great, useful. And here is the handheld, the MXW2. Looks a lot like many other Shure handheld transmitters, but again, it works completely differently in that it's fully integrated with the MXW system and how that handles frequency assignments and all of that other stuff. So it will be part of that system. It does feature the same interchangeable mic heads that all other Shure handhelds use as well. There's several different options or ways you can order the MXW2, but you could put any other mic head on there. You could even put a KSM9 on there if you wanted to. I don't know that that's necessarily needed in a conference situation, but if that's what the customer wanted, you could certainly accommodate that with the MXW2. The only thing it does not have is the headphone jack, because it would be a little bit what's the word I'm trying to say? I'm trying not to say silly, but I guess I'm going to say silly,
Awkward?
clumsy, awkward. Those are all good words to be holding a mic with a headphone plugged into it at the same time. But other than that, it's very similar to how the other transceivers work. So here we're looking at the what we affectionately call the ANI around here, which is the audio network interface. So this is the device that you would need if you want to get analog audio back out of the system. As I mentioned earlier, what's coming out of the access point transceiver is Dante. So if the rest of your sound system or the next device in your sound system is a Dante enabled device, then maybe you don't need the audio network interface. You just keep going through the Dante setup as needed. But however, if you'd rather just get 4 or 8 channels of analog output, then you also include the audio network interface in your setup. So like everything else we've seen so far, both 4 and 8 channel variations in terms of outputs, and then they each have inputs as well. So this is, I mentioned the access point transceiver can send audio back to the microphone transceivers, and how you get the audio into the access point would be through, one way would be through the inputs of the audio network interface. If you look up at the picture of the front panel there, you can see that you've got level select on your outputs there, line, auxiliary level, or mic level. You've got meters there where you can see the audio signal from each microphone. Look at it on a meter there, which is also shown in the GUI as well. You can solo mic channels to the headphones so you can hear each channel individually. You can even lock out the front panel if you'd like, which is often desirable. you can see that there's, if you're wondering what those slots are, there's a very quiet fan in there. Make sure the thing stays nice and cool. And if we look at the back panel, you can there see what the connectors look like on the 8-channel variation. We've followed the same color scheme that we use on the SCM820 digital automatic mixer, which is that orange always represents outputs and the black connectors represent inputs. So you can easily tell your input from your outputs there with those block connectors. And then note the 4 Ethernet ports on the right-hand side there. In fact, let's take a closer look at those as well. So we've basically got a 4-port gigabit switch built into the audio network interface here. And most importantly, port number 1, if you look closely, says class 0 PoE on it. So that is where you would connect your access point transceiver, because if you remember, I said earlier that needs PoE, and that's where you would get it from, is by connecting that to port number 1. As far as what it's showing here, sort of connected to the rest of the ports, that's really just sort of a general recommendation. The docking charger doesn't have to go to port number 2. Your PC doesn't have to go to port number 3. Any of the, again, it's a gigabit switch, so you could use any of the ports. But note that port number 4 can be set up to behave a little bit differently. We call that sort of the corporate network uplink, where if you want to have your MXW system accessible from a control aspect on your corporate network, but you don't want to send the Dante digital audio out over your corporate network, you can actually block Dante on port number 4. So that's what you would use to connect the system to the enterprise network, I guess, but keep your Dante traffic off of the network.
Another note on port 4 uplink is that it also blocks Bonjour Discovery. So the access point and the ANI run Bonjour Discovery to be viewable from our Shure Discovery application. However, if you plug them into port 4, that Bonjour will not go over that port. So it reduces traffic on your network, as well as gives you a bit more security, so that not anyone on your network can just find your device and go and change some settings on you.
Right. Great. And we didn't really talk about the Discovery application yet. If you saw the SCM820 webinar, you might remember when we talked about that. But basically, that is a little application you can run on your computer that will find both MXW and SCM820 components and then allow you to just double click that device and bring up the GUI for it. So the Discovery app is actually it comes with the product. You can download it from Shure.com, and again, that is one way to be able to find the devices from your computer. So let's take just a quick look at some setup basics here. If you are doing a setup that is only 4 mics or 8 mics, it's actually really, really easy to set up and doesn't even require you cracking open the computer if you don't want to. So let's take a look at a basic 8-channel microphone setup here, where we locate our access point somewhere in the room, again on the wall or the ceiling, depending on the kind of antenna coverage we're trying to get. And using standard Cat5e cabling, we can connect that directly to port number 1 of our audio network interface, remember, so that it gets PoE there. So we've placed each device where it needs to go, connect it up like that. And then we have to get the charger plugged in too. And again, it doesn't really matter which of the remaining ports we use, but the point is, using, again, Cat5e cabling, you put your charger on the network as well. So at this point, our wiring is complete. We haven't had to run any antenna cables. We haven't had to do any antenna distro. We haven't had to do anything but use two Ethernet cables to hook up our 8-channel system here. Now, an important part of this system is then is to form an association here. In other words, we need to tell this 8-channel access point that we want its 8 channels to come out of the ANI that it sees on the network. In other words, it doesn't automatically do this routing just by virtue of plugging them into each other. They can see each other, but they're not really doing anything yet. You can do this through the GUI, and we'll take a look at that in a little bit. But again, with a simple 8-channel system like this, simply by holding down the line and aux buttons on the front panel of the receiver, the auto association between all 3 of these devices happens. So now our network is set up. These devices are aware of each other. And this access point knows that there's a network charger out there, and it knows that there's an ANI, and the 8 channels of audio from that access point are coming to that ANI, and everything is set up and almost ready to go. The only thing we haven't done yet now is told which specific microphones we want to go to which specific channel of the access point. The charger actually has numbers on it, like each charging bay or charging slot is numbered. It would be 1 through 8 on an 8-channel version. And how we tell which microphones to go to which channel, the access point, is simply by putting them in the charger and pushing that link button on the charger. When you do that, the microphone in slot number 1 goes to access point channel number 1, and slot number 2 gets assigned to access point channel number 2, and that's it. That's how that association happens. So again, we ran 2 Ethernet cables, held down the line and mic buttons on the front panel of the audio network interface, push the link button on the charger. Now we just take our mics off the charger. They automatically find their own frequencies and assign themselves, and that's it. Our 8-channel mic system is set up and ready to go. And the link button, in case you're wondering, for you integrators out there, can be locked out so that you don't have to worry about someone changing the associations later on. So again, at the end of the day, the client puts the microphones back in the charger, the mics charge. It doesn't matter which slot they go back into because it's only for charging at this point. Take them out, run their meeting, and away you go. And you don't have to worry that someone looks and goes, hey, what does this link button do? You've defeated that functionality. What might the output of the ANI get connected to? Well, if it's a teleconference type situation, you probably would want to go to some sort of a teleconferencing mixer with some echo cancellation, like what you see here. Again, that's just a very straight ahead analog setup. Again, if you have a DSP that is Dante, again, you wouldn't even need the ANI. You would just be able to connect the access point directly to your Dante enabled DSP if that's what you're using, including our Shure SCM820. Again, digital automatic mixer could also take advantage of that. And the system can be scaled up. So if we needed to do a 24 mic system, we just, did it in 8-channel chunks here. So we have 3 8-channel access points, 3 ANIs, 3 network charging stations, and there's our 24 mic solution. What I haven't mentioned yet, which is probably important, and maybe somebody's already thinking they wanted to ask this, is how many microphones can we do with the MXW system? And the answer is 32. Environment dependent. When we talk about the fact that you don't really need to do frequency coordination for the system, the one thing you probably do want to do is a site scan. And we'll talk about how you can do that in a little bit here. So 32 is the maximum, and that's actually doable in a lot of locations I think we've looked at so far. So that would actually require then 4 of the 8-channel access points, 4 ANIs and 4 chargers to accomplish a 32 microphone setup. Here's we're just going to take a quick look at the GUI here because as seems to happen with this topic, we run long a little bit. But I just want to give you a quick look at this. So these are just screen captures here. We're not actually interacting with it at this point, but you can see there's 4 different tabs that are associated with the GUI. The first one is the monitor tab, which, as you might guess, allows you to monitor the system, and you can see for each channel how much battery life you have remaining, the RF signal strength, the audio signal. You can adjust the mic gain from the GUI. So again, you don't make gain adjustments on the actual mics themselves. You adjust it here from the GUI. And then you can either activate or mute microphones here. You can mute all the mics. You can put them into standby mode. You can have all kinds of control here. And like Paul was mentioning earlier, when a mic is in standby mode, again, you see that in the GUI. Like this gooseneck here on channel 3 is in standby mode. It tells you that right there. We can see that channel 4 is actually in the charger right now and charging. And in that case, it tells us how much longer it has to go until full charge, 30 minutes. The remaining mics, which are off and active, it tells you how long in hours and minutes until that battery is dead. Again, that can't be understated. And if it can't be overstated, I should say. And if you watched our rechargeable battery webinar, you learned about this feature, right? That's battery life in hours and minutes, accurate to within 15 minutes. That, compared to the bars that you get when you're using alkaline batteries and any other system is a huge thing. So that way, if you're saying, oh, we've got another hour to go on this meeting, are my batteries going to make it? And you go here and look and it says hour and a half, you're good to go. So that not only is it good that there was rechargeable batteries and they're green and that's all wonderful, but it actually makes your life easier because of the battery metrics that are available there. The configuration tab is where you would go to associate different components in an MXW system. So if you're not using the hold down the two buttons on the front panel of the ANI method, you would go here to the GUI where you would select, for example, group 1, you'd pick up access point and you'd say, I want to connect it to this charger and I want to connect it to this ANI for its output device. And when you've done that, then those connections, those associations are made for you. One thing we strongly encourage is naming your devices. And notice up in the right hand corner here under devices, you can actually give them unique names. And that's because the default names, actually these aren't even the default names here. We put in demo or something like that, but it's going to be the model number with a dash and then some other letters and numbers that probably don't mean anything to you. So you might call it, training room A and conference room B for each device, so that when you're looking at them in these pull down menus here, you actually know what you're dealing with. But anyway, there's nice instructions listed on the page here, so it's easy for you to figure out how to make the associations here. And note that you can also ID things as well. So if you're not sure which one you're dealing with here, if you click the ID button, it will actually flash the LEDs on the device so that you can see, I know which one this is now. The utility tab is like an inventory of everything that you can see on the network. And you can also see all of your IP addresses, what firmware versions you're on, all of that good stuff, as well as even more battery metrics. You can see battery capacity, which is how much capacity the battery has when it's fully charged versus a brand new battery, and cycle count, an accurate track of how many times the battery has been cycled, that is drained and then fully charged and then drained and then fully charged again. Something that's not available in any alkaline battery solution, but with our lithium ion solution, you can see a lot of good stuff there. And then finally, the preferences tab is where you set up how the system behaves, particularly the switches on the microphones themselves, those push buttons. So if you want them to be, toggle switches or cough switches or push to talk switches and how the LEDs behave, you can set all that up here. Note that you can also select how the microphone behaves when it's taken off the charger. So in active, that means when I take the mic off the charger, it finds a frequency and the mic is on. But you could have it set up so that it's muted when it comes off the charger, so that you don't have a bunch of open mics there that maybe you don't want. There's also some global settings you can make and choose, including selectable RF output power and some other things. But this is where you would, again, set up how the system is going to behave. Okay, changing gears a little bit. I mentioned earlier that the system operates in something that's called the DECT band. Maybe, Paul, you could tell us a little bit more about this frequency band and why we use it and what to watch out for when you're in there?
Sure. The DECT band is a unlicensed band from the FCC, so it's kind of there's a set of rules that you have to play by, and anyone can transmit in there. Most devices in that range are cordless headsets, cordless telephones, kind of those communication type devices. It's 1920 to 1930 megahertz, so it's up to like 1.9 gigahertz. It's important to note that that is not 2.4, so there's no Wi-Fi in that band, so you don't have to worry about that kind of interfering with your internet. So the other important part is that it's a kind of listen before you speak protocol. So to be a licensed DEC device, you need to follow this protocol, and that means that you won't really get any bad interference from other devices. If the other devices are compliant DEC devices, they'll notice you up on air transmitting and won't try to get a signal on top of you.
Great. Okay. And as I mentioned earlier, you can see we're talking about 32 compatible frequencies per zone with an MXW system. Again, how do you know if you can do 32 or not? Well, within the GUI, we've given you the ability, I should say, not just within the GUI, but with a GUI and an access point, you have the ability to actually go on site and do a spectrum scan that will show you how much of the spectrum, based on the pie chart you see in the graphic there, how much is actually going to be available for the MXW system to use. And then on top of that, it'll actually give you an estimated number of microphone channels. So you can see that, in this particular scenario, 76% of the 1.9 gigahertz range here is available, which conservatively translates into somewhere between 24 and 28 wireless mics, or aggressively means 30 to 32 channels. Paul, what's actually the difference between conservative and aggressive? Like, how do we arrive at those
Right.
numbers?
The conservative approach is kind of a throw the gear out on a table, and this is what you can kind of expect to get. So this is not following best RF practices. This is uh, kind of the baseline for what you can get. But the aggressive count is if you really are following best RF practices, mount your access point correctly, know your complete RF environment, know that there are no interferers around that can possibly take up some spectrum, and that's kind of the channel count you can expect. The great thing about this scanner is that the top pie chart is the current, and the bottom pie chart is kind of the worst case scenario. So if you're familiar with spectrum analyzers, you can think of the bottom as a peak hold. So that will kind of display the worst case scenario over the life of the scan. So you don't have to be looking at the scanner exactly when some interference pops up. It'll kind of save it there for you.
And note that you can run a scan for up to 24 hours. And that's often a good idea because if there is decked band activity in a particular facility, it might not be happening all day long. So if you just go in and scan once and go, hey, looks good, and then the call center wakes up an hour later and they're using decked phones, you wouldn't have caught that. So it's often good to let it go in there and scan for some amount of time, at least during business hours. So you can take a look at that minimum spectrum available chart and get a really accurate idea of what's going to happen.
Right, and it's important to note that that scanner is actually taking place on the access point itself, not on your laptop. So you can actually bring this access point to the site, start the scan with the PoE injector to power the access point, take your laptop, leave for the day, come back, and it's all saved on the access point for you.
That's good. The system also has selectable RF output levels as well. It can operate in low, medium, high, and what we call maximum power. How you decide what power level to use is basically um, on the size of the space that you're trying to cover. So for fairly small conference rooms, we only need maybe 30 feet of range maximum. You could get away with even the lowest power setting. If you're doing a big ballroom, then you might need to crank it all the way up to maximum power setting. Now if you're running a small number of systems, or the ballroom is the only room in the facility that's actually using mics, then max power is probably fine. But if you have several conference rooms that are relatively close to one another, and you're trying to get a larger number of systems on the air, then you might want to use lower power, because then with the reduced range of the system, that would allow you to then get another MXW rig somewhere else in the building up and running without having to worry about interference from the first system. So again, the system is doing its frequency coordination automatically, but there's still some RF related things you do need to pay attention to. Again, the power levels being one of them. As we always like to encourage people, more power is not necessarily always better. So be careful. So that brings us kind of to the end here, at least as far as what we wanted to talk about. Again, it's a system that we're pretty excited about because we think it's got a lot of features that are just absolutely perfect for this kind of market. And I'm sure we have lots of questions over there.
We do have a few.
All right. Before we take those, I just want to mention quickly, we do these webinars about once a month. And next up is completely changing gears and talking about wireless systems for guitar players. And we're going to have one of our own guitar player extraordinaires, Mr. Dave Mendez, lead that next webinar on everything you need to know about getting into wireless for your guitar player. You can also find other training events and archived versions of all of our past webinars at shure.com/training. So be sure to check that out if you're interested. And with that, yeah, I'm going to send it back to Cheryl and see what people want to know.
All right, we've got a couple of good questions today. First one off the bat, in talking about the push button on the microphone transceivers, can that push button be used as a voting button?
That's an interesting question. The button can be used to send an event to a third-party control string system, AMX Crestron type device. So if you have that capability in a Crestron device, you can record the button events. However, it's not really set up or designed to be that way.
Well, and it being that it's only one button, how would you know if you're voting yes or no?
Good point.
Okay, if you want to vote yes, press now.
Right.
I guess you could do it that way.
You
So
have some time
yeah,
to bend.
it's not really voting capability. I don't think was really designed as a feature of this system. So that's yeah, I suppose possible maybe depending on your control system, but
Right.
yeah.
Okay. Have a question about the Annie here in terms of the ports. Is there a particular reason why the ports on the Annie aren't XLR?
Well, kind of in this space, it's more standard to have the 3-pin kind of Phoenix connector. So just for all this gear sitting in a rack, it's most of those components are expecting this type of Phoenix connector, and also just for practical space reasons, fitting 8 XLR on the back of one rack unit is kind of hard.
Yeah.
So
Again, the advantage to the block connector, if that's not a connector that some people might be familiar with, is that it's a solderless connection. So for a permanent install where you're not plugging and unplugging the microphones all the time, you just simply connect your wires to the screw terminals on the block connector, plug it in, and you're done. So it really saves installation time as well versus XLRs.
Great. Okay. Question about the charger. One of our participants noticed that those gooseneck mics, those bases don't fit into the slots. They fit on, in a different way. And so when you're doing the link with the charger, what channels do the goosenecks get assigned to since they cover the two slots?
If I'm correct, and Paul, correct me if I'm wrong, it's on the 4-channel charger, they would get assigned to slots 1 and 2, or if you're using an 8-channel charger, slots 1 through 4.
correct. Exactly. So if you have an 8-channel access point and one 8-channel charger that you're using for 4 goosenecks, they will be slots 1 through 4. But you can also add an additional 8-channel charger to pair it to slots 5 through 8. I'm sorry.
Okay.
So you can use 2 8-channel chargers with one 8-channel access point to get 8 goosenecks.
Fantastic.
Great. And a question that sometimes comes up, and I'll just mention it now though, is you can't, like, let's say you have four goosenecks and the 4-channel charger, which again will only accommodate 2 goosenecks. You can't put in the first 2, hit link, take those 2 out, put in the next 2, and hit link. It
No,
doesn't work that way.
does not work that way.
So
And in the systems that we sell that have that multiple of the gooseneck chargers, it is accommodated for in the package with the amount of charging slots that you need.
correct.
So,
Right.
okay. Question about frequencies. The UK version of the system. What frequencies does that system use?
That uses the European DECT, which I believe is 1880 to 1900 megahertz, and that's actually 20 megahertz wide, as opposed to the US UPCS, which is the US equivalent of DECT, which is only 10 megahertz wide. So actually, in the UK, we'll support 64 channels as opposed to 32.
Awesome. Okay. When running the scanner, is there a way to tell the approximate time of day when that peak scan happens?
Unfortunately, not. There is no timer that we have built in right now, but that's a very good suggestion. Thank you.
We'll take it under advisement. Okay, a question here about how concerned does the client need to be with the DECT phone systems when coordinating site frequencies?
Fairly concerned, depending upon where they are in relation to the system that you're installing. Um, those devices can use up a fair amount of spectrum. So if you want to get a maximum channel count, say a 32 channel system, I would be concerned. However, if you have smaller rooms, if you're just doing 4 or 8 channels, even 16 channels, it would be best to obviously do a spectrum scan prior to the installation. But I would be pretty comfortable, thinking you can get at least an 8-channel system up there.
Okay. And speaking of sort of the DECT band, there's a question here that if someone is using their own spectrum analyzer, what should they be looking for in a pre-installation scan in that DECT band?
So you've stumbled upon something. So it's interesting because the DEX scheme is actually both time and frequency. So if you look at those at that band in just a normal spectrum analyzer, you'll almost always see energy there if there's a device up. However, you won't have the time aspect to know how much of that frequency is actually being used. So it's kind of it might hurt your brain a little bit, but these devices don't occupy kind of this one frequency for all of time like UHF. So with UHF, you dial up your transmitter to 525.52 megahertz, and that is transmitting 100% of that time on that frequency. These microphones only transmit for fractions of a second. So without that time kind of axis on your spectrum analyzer, you really won't have an idea of how much of it is actually in use.
So a spectrum analyzer really is not a useful tool for actually determining how many channels of MXW.
Correct, correct. You would need your spectrum analyzer to be time synced to our network. Some of the more advanced ones you can do that, but it's pretty advanced.
It's
and
kind
pretty
of getting
out there.
involved, yeah.
Yeah.
All right. Here's another one. Is there a mixed output to feed a hearing system, such as induction loop or infrared system?
Well, in that case, instead of using the ANI, or in addition to using the ANI, I guess you would need some sort of a mixer, right? That would mix the microphone signals together. Again, one way to do that is with the SCM820 digital audio mixer, which the Dante enabled version of it. In that case, you would just have the 8 channels from your access point connected via Dante to the SCM820, which actually has 2 outputs. So you could use one output to feed your PA and the other output to feed the assistive listening system if that's what's needed. So again, the ANI is it's the one component here that I would, I guess, classify as optional, right? It's a way to get analog audio out of the system, but if you've got other Dante devices, you could certainly use those instead to get the audio wherever you need it to go.
Yeah, that's right, Gino. The one thing to remember though is that the SCM820 does not have PoE on it. So if you are going to connect it straight to an 820, you'll need a separate PoE injector.
And on those lines too, we mentioned earlier that the switch on the ANI is a gigabit switch, and if you're using your own network switches, they should also be gigabit. For any Dante network, it's highly encouraged to always use gigabit switches. So keep that in mind for applies to MXW as well.
Fantastic. All right, got another question here. In terms of the gooseneck transceiver mic bases, can you connect your own microphones to that mic base?
Well, I suppose it might be possible, but that's a 6-pin modular connector with a threaded base that is pretty specific to the MX405 410s. It's not like an XLR or something like that. So it would be quite an engineering effort on your own part to come up with something that would connect and look good.
Right. If you already have some 405 410s from SLX, then you can basically unscrew those and put them in this base. But yeah, that's the only microphone that it really supports.
Okay, great. When running a full 32 channel system, can you run all 32 channels over Dante only, or will you need the ANI to expand to 32 channels?
I think if I understand the question correctly, you will need 4 8-channel ANIs to get all 32 analog outputs. Conversely, you could put that all over one Dante Ethernet cable as well. So
right, if you're connecting to a 32 channel Yamaha CL series console, which has Dante, then you wouldn't need the ANI. You could just bring up those 32 channels on your Yamaha board.
Fantastic. And I think there's only one last thing here, and it's more of a comment, and it just says impressive. And I'm going to have to agree with that.
What a great question to end on.
Best question we've ever had. So I think that just about wraps up our questions here. If you do have any other questions that we didn't get to, you can send those to support@shure.com, and one of our applications engineers will be happy to give you whatever answers you need. So I believe that just about wraps us up. We hope to see you on our next webinar, and have a great day.
thanks, guys. This was fun.